So in 8.42, there's a question that says to test for convergence or divergence on this series. I didn't write it down. It's question 4. When we look at it, the keys should be the fact that there is an n in the base and an n in the exponent. So as soon as there's an n in both locations, it's not a p-test and it's not a geometric series. So we're probably going to have to use the ratio test. As soon as we see those, we think, aha, ratio test. So to do the ratio test, we're going to let L equal the limit as n goes to infinity of the absolute value. Remember, it's actually a n plus 1 over a n, but since they're all fractions, I'm going to write it as a n plus 1 times 1 over a n. I'm just going to take the reciprocal. So plugging in the n plus 1s, you get negative 2 to the n plus 1 over n plus 1 times 5 to the n plus 1. Then when you multiply by the reciprocal, the numerator has an n and a 5 to the n, and the denominator has a negative 2 to the n. The absolute values, the n's won't matter because n is going to infinity, they're all positive. The 5's will always be positive, and the negative 2's, if you end up with a negative, it'll kill it. So all that's left is the limit as n goes to infinity. We'll write it once in simplified form that I usually don't. 2 to the n plus 1 times 5 to the n times n over, I'm comparing like terms. So 2 to the n will pair up with the 2 vertically, 5 to the n plus 1, and n plus 1. Now it's easier to see how things cancel. The absolute values went away, we said y. So this L is equal to the limit as n goes to infinity of the 2's cancel to give me a 2, and the 5's cancel to give me a 5 in the denominator. And we still have on top an n and an n plus 1. Everybody's tempted to cancel those, but you can't. We're taking a limit, and there's addition with this n plus 1, so you can't cancel them. It still ends up being 2 over 5. You could do it with leading coefficients. You could do it by dividing. So let's write it once with division to make sure we understand what I mean by that. Limit as n goes to infinity of 2n times 1 over n over 5n plus 5 times 1 over n. So I'm just multiplying my problem by the number 1, because anything over itself is a 1, but I'm multiplying it by a convenient form of 1. When I distribute, this is the limit as n goes to infinity of 2 over 5 plus 5 divided by n. Now, as n goes to infinity, 2 and 5 stay still, and the 5 over n goes to 0. So this is 2/5. The ratio test says take your L equals 2/5, and you want to compare that to 1. It's pretty clear that 2/5 is less than 1. So the series by the ratio test, the series from n equals 1 to infinity, negative 2 to the n over n times 5 to the n, converges absolutely. It seems silly to say that, because we always want to know if it converges or not. But like we mentioned before in the alternating series section, if it converges conditionally, that's important. So the fact that it converges absolutely is also important. By the ratio test, it converges absolutely.